world's hardest problems are about to meet their match. Quantum technology has the power to revolutionize drug discovery, reimagine material science, transform financial modeling, and secure our digital future. IonQ isn't just building quantum computers. We're developing the world's first and only complete quantum platform, with products and services that span quantum compute, networking, security, sensing, and space infrastructure. IonQ is at the forefront of practical, scalable quantum technology, accelerating the path to commercial quantum advantage. The quantum era is here, and it runs on IonQ. IonQ, the only full-stack quantum platform.
Good morning. How are we today? I never imagined that the FCC would be such a hard act to follow, but I'm thrilled to be here today. My name is Jordan Shapiro, and I am the President and General Manager of Quantum Networking, Sensing, and Security at IonQ. We're thrilled to be a platinum partner and of this conference, and to talk to you a little bit today about the intersection of technology and business, government and regulation, policy, education, and space, and how all of that comes together here in the DMV. I'm going to walk you through today a little bit about IonQ's technology and what it means to be in the quantum technology business. Raise your hand if we have some passing familiarity with quantum. A little bit, okay. I'll give you the high level. I would normally say it's not rocket science, but in this case, it is today. So we'll talk through our technology. We'll talk through some of the challenges that we see at the intersection of quantum and space that we're looking to solve at IonQ, and then the opportunities for doing so right here in the DMV as well. The first thing to know is that IonQ has been in the quantum technology area for many years. We are built on the back of 30-plus years of research started by our co-founder, Chris Monroe, who discovered the world's first quantum logic gate, performed this gate, which showed that you could do computation between 2 quantum bits, or qubits, way back in the day. Fast forward towards early 2020s, we took IonQ public, and at the time, we're the first and still the only company that is on all 3 major public clouds: AWS, Google Cloud Platform, and Microsoft Azure. Taking this technology that was built in lab for quantum computing and getting it out into the hands of commercial customers for live applications. Today, IonQ is building applications at the cutting edge of virtually every industry, and we're targeting those applications to have as much societal impact as possible. So we'll talk about that as well. IonQ is the world's leading quantum platform technology company, and we do that on using amazing resources that we have at the company. It's important to know that IonQ has over 1,100 patents and patents pending in our portfolio. We've got north of 1,000 employees, many of whom hold graduate degrees in quantum and other forms of science and technology, and that we're also very well capitalized, which, as we think about the intersection of space and quantum and governance, having the capital to continue to build this technology is critical. As of our last earnings call, we had $3.5 billion of cash and investments on the balance sheet. IonQ, like I mentioned, is partnering with leading government providers and customers, partners, enterprise customers as well, to build applications at the cutting edge of quantum technology. Take, for example, our work with Hyundai, which is focused on everything from battery chemistry or optical recognition for autonomous vehicles. Take our work with Airbus, which is focused on cargo loading and logistics, or even our work with AstraZeneca and NVIDIA on biopharma. These are all areas that quantum technology can intersect with. And we work with partners and government customers as well on all these types of areas. So what is quantum technology at the highest level? I'll start with quantum computing, which was really the core technology that IonQ began with 30 years ago. Quantum computing is meant to solve problems that otherwise we would never solve with classical computers as we know them today. Classical computers are based on bits, zeros, and ones, and bits are great at solving a whole number of problems, but there are certain problems that will take too long or are inefficient to solve using our classical computers. And the probably most poignant example of that today is we see increasing loads on AI and data centers across the world today. And then beyond that, there are certain problems that we'll never solve with our classical computers because they're just too complex, or you'd have to turn every atom in the universe into a bit in order to make it happen. And that's where quantum computers are really dramatically useful. In addition to quantum computing, IonQ was always built on this modular approach of connecting different quantum devices together. Why would you want to do that? Well, from a computing perspective, you might want to cluster multiple quantum computers together to form a more powerful computer. You may also want to connect computers at vast distances to run distributed problems. We do that classically today. Additionally, quantum networking, this area of building connections between systems, allows you to think about connecting a whole manner of quantum devices that might not be computers to the same network, and that has certain advantages as well. And we're focused on doing this on the ground today and also in space. I'll tell you why in a few minutes. With that networking, we also look at quantum as a way to secure communications. And it's critical to recognize that with the growth of quantum computing, there's also a threat of quantum attack and hacking, which we'll talk through. So we focus on quantum security as well. We think as a responsible actor who is building quantum computers, we also need to provide protection from all forms of quantum and classical attacks. Last but not least, we have quantum sensing technology. And that technology allows you to use the same phenomenon of quantum mechanics that underlies all of these areas to think about perturbations in the environment around us. And we can sense things like time and frequency, rotation, gravity, and those are critical for applications in the world today. In each of these areas, IonQ is leading. We have top performant technology, the most robust technology, the most commercialized technology. So I'm excited to dive into those today. With all this technology, IonQ approaches the space market with a recognition that the paradigm has changed on space over the last years. It's a 60-plus-year-old industry, but as you just heard, the space industry is continuing to develop at a very rapid velocity. And with all of that acceleration, we need to consider how the paradigm shifted and what new technology we can bring to bear. Take, for example, the challenge of additional proliferation of LEO, and the fact that we can't necessarily today trust all of the information that's being uplinked and downlinked from our satellites because there are possible concerns of interception of those signals. Or take the focus on national sovereignty, which we've seen rising, especially in recent months and years with the current geopolitical environment. There's a focus on having one's own constellation and not just using a generic public constellation. Last but not least, there's a question of pace of data. I mentioned the AI boom and how that's impacting us today. The pace that we want to send signals back and forth requires new technology to do that at higher bandwidths. So these are all just examples of the technology that we need to keep in focus today and why IonQ thinks that quantum has a real play in space. IonQ is building technology that crosses every domain, whether that be sea, land, air, and space. We'll give you some examples, but we don't think of space as separate from the rest of the ecosystem. It's all one composite. And that's one of the reasons that we've been so active in building our portfolio around ground-based technologies and thinking about how those apply into space as well. To give you a few examples, IonQ thinks of itself as a portfolio platform company. I gave you the high-level definitions of the areas that we operate in computing and sensing, in space and ground infrastructure, in cybersecurity and networking. But I'd also comment that IonQ has been focused on bringing together the world's best technology in one commercial platform. And so we've made a number of acquisitions in addition to our organic growth over the past years. And these are technologies like Skyloom, which is an OCT company that can increase the bandwidth of space communications, which is going to be critical for classical and quantum communication in the future. Or take LightSync, a company that builds the world's best quantum memories. This is technology that allows you to store quantum information and also allows you to do things like go longer distances with that information and really think about it from a more enterprise perspective. So given the challenges in space, we have a challenge and we have technology to potentially solve that challenge. How is IonQ uniting that? How are we bringing it all together? I'm going to give you a few examples today. The first two examples come from our quantum sensing side of the business. Our quantum sensors, like I mentioned, are some of the most performant, most accurate sensors in the world today, and they're also, in many ways, the most robust sensors as we continue to commercialize and productize this technology. So take, for example, our alt-PNT technology, our forms of alternative positioning, navigation, and timing that can allow us to operate in GPS-denied environments. Why is this an issue? Well, if you're reading the news, there are GPS-denied environments proliferating all over the world as we see conflicts continue to increase. So take, for example, in Venezuela, where there was recently GPS denial happening. Or in Ukraine, we've seen this, especially with the proliferations of drones on the battlefield, where those drones are being hacked out of the sky. And so having different forms of reckoning on where you are from a PNT perspective, whether that be by looking at the specific gravity of where you are in the planet, by looking from a magnetometry perspective of what's the magnetic force around me, that allows me to do other forms of positioning without having to rely upon GPS, which can be key in these environments. One such example of us taking this into space is that last year we announced that on the X-37B, one of our quantum gyroscopes was experimented on that plane. And that's Boeing's space plane that is used by Space Force today for normally top secret experiments. We were lucky enough to be able to publish the news of our work together. And we think that those sensors can be used in a variety of applications. I'm mentioning a defense use case or two, but there are also commercial applications of the same sensors, be it for oil and gas, for environmental sensing, et cetera. Next, we talked about alternative forms of PNT and GPS, but GPS itself can also be improved with space infrastructure and quantum coming together. So we build the world's most precise optical clocks at IonQ. And in addition to being most precise clocks, these are the size of, call it 30 liters, so a couple units in a rack, if you're familiar with rack-mounted systems. And so that makes them more robust. We've taken those and put them on naval vessels at sea. We've put them on trucks on land. We've put them in the air and done flight testing, and we're also working to put them in space. And that's one of the reasons that IonQ has been so focused on space and has acquired a platform like Capella. The Capella platform, for those familiar, and if you're not, please visit our booth today, allows us to do very modular satellite buses that allow us to integrate a payload so you can contemplate putting one of the most precise optical clocks in the world into space. Why would that matter? These time signatures are crucial for GPS, and if we can get you more precise time, you can take GPS from a meter range accuracy down to a scale closer to a millimeter, and that totally changes the game on positioning, both from a commercial perspective and from a defense perspective. I'll comment briefly on security as well. Like I mentioned, if you are going to create very powerful quantum computers, you also need to be able to defend against all manner of quantum attacks. One of the ways that we can do that is using the same physics of quantum mechanics to encode information. And today, we have a technology called quantum key distribution that does that, using commercial fiber on the ground today. That's very commercialized with live customers, be they telcos or financial institutions. But there is a problem on this as well, which is often you want to get off of that fiber infrastructure, because maybe it doesn't span the distance you want, or maybe you want to go across an ocean. So we'll talk about how we're using space to do that. Similarly, I mentioned the broad platform of quantum networking, where you might want to connect all manner of quantum devices together. IonQ thinks about these devices, and we're actively developing and maturing them so that they can fit into enterprise environments today. We've delivered a quantum network to Air Force Research Lab in Rome, New York. We've delivered another one to EPB in Chattanooga, a local utility company. And so we're building these in commercial settings and government settings, and this is the way that will connect those quantum computers and allow for ultra-secure communications, but also for more powerful compute, more interesting distributed problems that we can solve. So both that security use case and that quantum networking use case rely upon commercial fiber for the most part. But one of the reasons IonQ is so excited about space is that we recognize the need to go broader in terms of geographic footprint. This is just an example of how we might envision a network across the US where you'll see these orange nodes of what it would look like to have a ground network that's using the commercial fiber, but also the opportunity to go from those ground networks up to space, to uplink, into a Capella satellite, maybe outfitted with a Skylum OCT. All of these are IonQ technologies today. And then from that satellite, pass the signal across a long distance, thereby connecting local quantum networks into a national network. Lastly, I want to comment on a few ways that we're making this possible today. So you've now seen the technical examples. IonQ is really committed to the DMV. We were founded here as a spin-out of the University of Maryland and Duke as well, but we've always had our headquarters at University of Maryland. And being in the DMV, we care very deeply about the collaborations and partnerships with our government partners. So IonQ Federal has formed over the last year or so to really take our federal operations and our government partnerships to new heights with the US and our allies internationally. I am very proud to have such incredible colleagues around the table that I get to work with every day. You have Robert Cardillo, who previously ran NGA, the National Geospatial Intelligence Agency. Katie Arrington is the latest addition to our team, the CIO of IonQ. She just came to us as CIO of Department of War immediately beforehand. So we're really focused on our presence with the government and continuing to build long-lasting partnerships. Similarly, I mentioned we're focused on this region, on the DMV, and that's why it's so energizing for me to see all in one conference, educational outreach and government partnerships and regulatory partnerships. And IonQ is part of Maryland's billion-dollar Capital of Quantum initiative. We announced this last year. That dedicates our commitment to staying headquartered in Maryland and also to continuing to develop the educational and the commercial ecosystem right here in the DMV. So this was just a high-level presentation today of our technology and how we are thinking about working together. IonQ operates in a way that we can build US-only technology, but we can also work with allies and build a global technology platform. And the reason we're doing this is for that societal impact that comes together at the convergence of quantum and space technologies. We envision a world where you have much more secured communications that cannot be hacked in the same way that you see today. We envision a world that's better synchronized, be that in GPS-denied environments or just with better GPS altogether. We envision a world that has sovereign systems that offers full quantum solutions across the stack, from computing to networking to sensing to security, all in a package for government customers and for enterprise customers that want to see a system that they can call their own. That's why we're so excited to be here, to be collaborating with our partners across the ecosystem, and to be building the future at IonQ today. Thank you.